Hello, today we're recording our project for Logic Design 1 Lab. This is an encryption system project. It's made out of a shift register, a memory storing unit, and some encryption units, which I'll explain in a minute. What we have here, initially we have a user input, let's say 6. Right now we are going to load the data. We need a clock to load the data. And then we'll put our shift register to shift mode, and we'll shift our data over to our storage flip-flops. Once they're stored, the data goes to our encryption stages, and we can see it here. The encryption stage is basically an adder with an XOR gate, and depending on the input that's randomly generated, a random number could either be added or subtracted from our input. So we have 3 stages of encryption, and as you see, we have selected some preset numbers. This is a random number generator that tells the adders whether to add or subtract. Now once the data goes through each stage, then it gets decrypted through the opposite, either addition or subtraction, than it was done in the first stages. Here on these 7-segment displays, we have the input data, we also have the encrypted data, and we have the output data. As you can see, the output is the same as the input. That is it. Thank you for your time. Here we have a fully implemented circuit comprised of a loading area where we have a shift register made of D flip-flops, some AND and OR gates. We also have a storage section made of D flip-flops where our data is stored. After our data is being input into the storage unit, it goes over to our encryption and decryption stages. Here we have 2 encryption stages and 2 decryption stages. So let's do an example. Right now we'll load a number in. First we put our shift register in load mode. Once the data is loaded, we'll put it into shift mode and give it a couple of clocks. Okay, at this time you can see that our input data is the same as our output data. We have our input data is 4. It goes into the encryption, where a number is either added or subtracted. In this case, we're adding 6. On the second stage, we're also adding the number 2. Afterwards, we're subtracting 2, and we're subtracting 6 to get the original data. Let's do another example. We'll change the input. We'll put it into load mode again. We'll give it a clock. At this point, our data is loaded. We'll go to shift mode again and go for the clock. And as you can see, our data is loaded. Our input is 6. Our memory that's stored into the D flip-flop is 6. The data goes to the encryption stages. This is our encrypted data. As you see, it does not match the output. After the data is decrypted, it matches the output, which is the same as our input. Further, if we change the values that are being added or subtracted on both the encryption and decryption, you'll see we end up with the same output. So it does not matter what values we're adding or subtracting. So in this case, we completely changed the values, and as you see, we still have the same output. In addition, we can also change the subtraction and addition. And we changed from subtraction to addition, still getting the same output. In this case, it so happens to be that our encrypted data is the same as our decrypted data. So that's something that we could possibly work on in the future, because even though, as you can see, the data does change in between the stages, in this particular case we have our encrypted data matches the decrypted data. So this is actually an interesting scenario that we happen to stumble on by accident.